So this strategy looks at how I can combine the strategy of partial quotients to the area model, which is something students have experience with in multiplication. So it really makes that good multiplication division connection, and they can see how the two are related. So on this problem where I'm dividing 680 by 5, to use the area model, we're kind of doing it, we're building it as we go, because now my area is 680, and I don't know what one of the dimensions is. I know that I start with one dimension, that's a length of 5, and I need to build an area that gets up to 680. That's quite a ways to go, so I'm kind of thinking that I want to use a larger number and do a length of 100. And that will give me an area of 500. Using these in connection really helps students start to see that if I multiply 5 by 100, I've already taken care of 500 of my 680. So I still have 180 left to compose with my area model. So again, doing these together helps students not only keep track of over here, but make sense of what this process is in relation to something they've already had exposure to. So I know I have to get to 180, so taking out a dimension of 100 is not going to work anymore. So maybe then I think, okay, well I know 5 times 20 is 100. So I have this next dimension of 20. Which leaves me left with 80 left. Again, I know I can't take out another 20, but it might be useful to take out a distance of 10. That would give me an area of 50. While it might seem kind of like a long process to do it this way, it's something that makes sense to the students because they're finding facts that they know. They're using information that they already know to access something that's a little bit more difficult for them. And again, they're making that division and multiplication connection. So then to find what my complete quotient is, I'm going to add up all of my partial quotients because that will give me this total distance or this total length of my dimension. So it'd be 120, 130, 136.